सो हेलो नमस्कार टू द ऑल केमिस्ट्री लवर्स डॉक्टर्स एंड इंजीनियर्स ऑफ द नियर फ्यूचर। मैं विजय कुमार सोनी आपका हार्दिक स्वागत करता हूं इन केमिस्ट्री वाला चैनल रिगार्डिंग टू योर वन एंड ओनली केमिस्ट्री। In previous video we have discussed about the just meaning of batteries as a primary and secondary. As a primary batteries we have taken just example of or deeply study of just dry cell and mercury cell. Regarding to just your secondary cell we have discussed about the lead storage cell, that is also called as lead accumulator cell, because they stores energy as a electrical energy. While if we'll go with the another, then that is the just your NICD cell, which is used in cordless phone, wireless phone, pagers and so and so. So we have discussed about these two types of the cell. Now it's time to discuss about the important cell, that is the fuel cell. पर्टिकुलर इस पर बेस्ड क्वेश्चन भी पिछली बार आ चुका है सीबीएसई में जस्ट 2022 में. Now what will be about 23 we'll see. Now the time to discuss about the just your fuel cell. So this is the fuel cell. First of all we'll go with the meaning of fuel cell. Means cell which changes just chemical energy, and here chemical energy will be in the form of fuel. So we can say chemical energy or fuel energy into just electrical energy. They are known as just your fuel cell, called as fuel cell. If I'll go with the just further, then these also called as Bacon cell. There is a lot of example regarding to the fuel cell, but here we'll take just as an example H2O2 cell. H2O2 cell. This is the best example regarding to fuel cell. If we'll go with these cells, then these are eco-friendly in nature. Eco-friendly just cell, because these does not causes we can say pollution as a fuel. H2 और O2 की जगह हम क्या क्या यूज कर सकते हैं एज फ्यूल? वी कैन यूज CH4 मीथेन गैस, C2H6 ethane gas, C3H8 propane gas, and butane gas also, C4H10. These are used in the form of just fuel which changes just by the combustion, gives electrical energy. Now just structure and reactions of the H2O2 cell. If we'll go with the just structure of the H2O2 cell, then it exists following structure. This is the H2O2 cell diagrammatically. Here will be two porous platinum or titanium electrode filled with the platinum powder. These are the just one of the cathode and another anode. We can denote is as follows. These are the porous electrode as a anode. This will be your anode, and from the right side it will your cathode. This is the cathode as a positive terminal. Cathode. From the side of cathode it will be flow of O2 gas as a fuel, and from the side of anode it will be flow of H2 gas. Here as an electrolyte we'll use either acid or base. This is the diagram of fuel cell. fuel cell. These are the porous, just titanium electrode, titanium or platinum electrode. You can say carbon electrode also, titanium or carbon electrode filled with carbon powder, which acts as a catalyst for these kind of the cell. And here is the removal of water in the form of S2O, you can say. So this was about the structure of S2O2 cell. Now I would like to go with the just reaction. So there are just two electrodes, as one of the cathode and another anode. So these are the cell reaction. As an electrolyte, here I will use of just 4 of KOH. We can use both electrolyte, acid or base also. As electrolyte we can use acid or base. So first of all, it dissociate in 4 of K plus and just 4 of OH minus. First of all, this is the time to discuss about the anode. From the side of anode, it will flow of S2 gas in the form of 2 of S2. Here will just 4 of OH minus. Over the anode, it will be loss of electron. So here will formation of 4 of S2O by the loss of 4 electron. Now from the side of cathode, it will be use of just 2 of, you can say O2. 2 of O2, this is the just dilute medium we are going to use as a electrolyte, acid or base, KOH dilute. So what will be, here will use of just 2 of S2O. Then what the reaction will be as follows. This is the 2 of S2O changes in 4 of OH minus. This is the, we can use O2. So this is the 4 of OH minus, and here will use of 4 electron also. 4 electron changes in 4 of OH minus. This is the oxidation, while this is the reduction reaction regarding to the just your fuel cell. Now the time to discuss about the very important, that is the net cell reaction, overall reaction. This is the overall reaction, or you can say discharging reaction. If we'll go with this reaction, then you can see here is the 4 electron, here is the 4 electron remains cancelled. Concentration of electrolyte remains constant. So you can say EMF will be constant. With a constant value. What is that? We'll discuss, no doubt. So these 4 of OH minus remains cancelled. These 4 of S2 remains cancelled by just 2 of S2O. So the net cell reaction will be your 2 of H2 plus O2 gives you 2 of S2O. This is the net cell reaction. Now the time to discuss about the very important, that is the EMF of the cell, that is 1.299 volt as a constant EMF. One of the important application where these can be used. So these cell are used in many of space program like Apollo satellite program and in Doordarshan Kendra also. So this was about the just fuel cell and about the structure and reactions with the EMF of the cell. Go through properly with this material. There is a lot of question in board examination. Which of the fuel will be used in spite of just S2 and O2? Then you can say methane, ethane, propane, and butane. Just EMF of the cell, that is the 1.299 volt. Just use of the cell in Apollo satellite program and Doordarshan Kendra also. Just changes fuel energy to electrical energy, also called as Becquerel cell, and does not causes pollution. These are the important points regarding to the cell. Now we'll go with the just last topic of the cell. This chapter, what is that? That is the corrosion. It's very important topic because of it will be a lot of short note. They may ask you just what is the meaning of corrosion, may ask you what is the meaning of sacrificial protection, may ask you what is the galvanization, may ask you which of the anti substance are used to prevent the corrosion. About just 19 to 20% iron decomposes per year in the form of rusting. So it's a great loss to the industry of iron. So now the time to discuss about the corrosion. This is the next topic, corrosion. You can say just metal surface, yeah, you can say process in which formation of in which metals degrades by the formation of unwanted carbonates, oxides, sulfates, and halides in the contact of atmosphere, in the contact of atmosphere is called as just corrosion. Atmosphere is called as corrosion. Particular मेटल सरफेस पर कार्बोनेट्स, बाइकार्बोनेट्स, सल्फेट्स और हैलाइड्स का फॉर्मेशन होता है जिससे पर्टिकुलर वो मेटल कंटिन्यूअसली डिग्रेड होती चली जाती हैं एंड द डिग्रेडेशन method or this process is called as just corrosion. If we'll go with the just examples of the corrosion, then there are a lot of example regarding to corrosion. First we can take just as a blackening of, this is the blackening of silver, चांदी का काला पड़ना, just formation of green substance over the surface of copper, and you can say rusting of iron are the best example rusting of iron are the best example for the just corrosion. If we'll go with the corrosion, then it is exothermic process. Exothermic process means during the process during the process, release of energy or heat take place the basic cause of corrosion are presence of H2O, O2, CO2, SO2, SO3 and HCl in the atmosphere. This causes corrosion. That's why these also called as corrosive substances, which causes corrosion. If we'll go with the just further as a types of corrosion, then there are two types of the corrosion. One of the is your dry corrosion. Dry corrosion, it is called as just chemical corrosion. Chemical corrosion, we can say it is caused by O2, SO2, SO3 and HCl. It is also called as just your chemical corrosion. While the another is your wet corrosion. Wet corrosion, also called as just electrochemical corrosion. Electrochemical corrosion. Why? Because of it will formation of a small electrochemical cell over the surface of the iron metal. That's why it is called as electrochemical corrosion also. If we'll go with the just this is basically causes in the presence of moisture in air. For this we can take the example of rusting of iron. Rusting of iron is the best example for the just wet corrosion. So this was about the just the meaning of corrosion, cause of corrosion, exothermic process, types of the corrosion as a dry and wet corrosion. Now we'll go with the just mechanism of rusting of iron. Go through properly with this matter because it's too important. And this is the last topic of this chapter also. After this, we'll go with the alcohol, phenol, and ether as another second chapter because of in previous we have discussed about the haloalkane and haloarine. So now the time to discuss about the rusting of iron regarding to the corrosion. And this topic is also important for the class 10th. So if there is anybody as your just brother and sister, younger brother and sister who are in class 10th, they can study this matter from here. So this is the rusting of iron. If metal surface is smooth, then the probability of rusting of iron will be lesser than the rough surface. मीन्स पर्टिकुलर अगर मेटल की सरफेस रफ है तो कोरोजन ज़्यादा होगा, और अगर मेटल की सरफेस स्मूथ है तो कोरोजन की प्रोबेबिलिटी कम होगी. सो दिस इज द प्रोसेस ऑफ रस्टिंग ऑफ आयरन. Rusting of iron. For this we can take the example as follows. This is the suppose rough surface of the metal, as you can say iron. This is the block of the iron, and suppose this is your water droplet in the form of moisture, where it will be solubility of O2 and CO2. CO2, this is the water drop. Water drop, this is the metal, iron metal block, you can say. Over here will formation of a red brown substance over here, which is called as rust. The formula for rust is your Fe2O3.XS2O. This is the X of S2O, formula of the rust. And here S2O will react with the CO2 to form H2CO3 as a carbonic acid, which acts as an electrolyte. And this is the metal surface. Metal surface. And this is the diagram regarding to rusting of iron. Rusting of iron. Here is the formation of electrochemical just process or cell. That's why it is also called as electrochemical corrosion. First of all, we'll go with the just electrolyte. So CO2 particular, by dissolving water, it gives you H2O plus CO2 gives you H2CO3. This is called as carbonic acid, and carbonic acid acts as an electrolyte. Resultant process will fast. So this is the 2 of H2CO3 according to stoichiometry. Changes in 4 of H plus, and this is the 2 of CO3 2 minus. First of all, we'll go with the anode, and metal surface acts as an anode. So anode means here will oxidation, loss of electron. So Fe changes in Fe plus 2 by the loss of 2 electron. As an anode will take just 2 of Fe according to stoichiometry. Here is the 2 of Fe plus 2 with the loss of 4 electron, and this process is called as oxidation reaction. Oxidation reaction. Now I would like to go with the cathode. This is the cathode. Regarding to cathode, what will be? Just remember one thing, जो एटमॉस्फेयर में आपके पास में ये जो डिजोल्व हुआ है O2 और CO2, ये डिजोल्व होकर के H2CO3 के साथ में पर्टिकुलर यहाँ H प्लस आयन इस प्रोसेस को फास्ट करने का काम करेंगे. सो व्हाट विल बी द रिएक्शन ऑन कैथोड? इट विल बी योर 4 of H plus. This is the O2, and here is the gain of electron as a 4 electron. So the reaction will be your 2 of H2O. Here will formation of water. Now I would like to go with the net cell reaction. So from 4 electron to 4 electron, these remains cancelled. This is called as reduction reaction. Reduction reaction. Just net cell reaction will be net cell reaction during the process of corrosion. Here is the 2 of Fe. So this is the 2 of Fe plus, this is the 4 of H plus O2, changes in 2 of Fe plus 2, 2 of Fe plus 2 and just 2 of S2. This is the net cell reaction, or you can say just a result of reaction of cathode and anode. ये वाली रिएक्शन आपके पास में बड़ी इंपॉर्टेंट है. नाउ व्हाट इज द इंपॉर्टेंट थिंग, ये जो आपके पास में Fe+2 बना है, नाउ फॉर्मिंग Fe+2, just you can say ferrous iron, what will be the changes in just Fe2O3 iron oxide, changes in Fe2O3 on reaction with further O2 या you can say air. तो रिएक्शन क्या होगी आपके पास में, फॉर दिस वी कैन टेक जस्ट this is the 4 of Fe+2. Regarding to this, we have taken the balance reaction as a 4 of just H plus and OH minus. And now the time to discuss about the 4 of Fe+2. 4 of Fe+2. If we'll go with the further, then we can take just O2 and S2O moisture as a 4 of S2O. So the reaction will be, this is the 4 of Fe+2, then it will formation of 2 of Fe2O3 and 2 of Fe. Fe is balance, oxygen is 3 to the 6, so here is 2 and 4 6, rest it will be release of 8 of H plus, and further this Fe2O3 becomes hydrated and changes in a red brown Fe2O3 dot X of S2O, changes in red brown powder which is called as rust. So this was about the process of rusting of iron. First of all, you will say just it will be participation of CO2 dissolving in water droplet and formation of carbonic acid. Here just carbonic acid acts as an electrolyte, dissociates in 4 of H plus and CO3 2 minus. The electrolyte increases to the rate of reaction. So first of all, anode changes over the anode, metal surface will be as an anode and loses electron, get oxidation process, and just forming carbonic acid and the dioxygen of the atmosphere changes in water. Natural reaction is given. Further, this forming Fe+2 ion reacts with the just air and moisture and changes in iron oxide. Further, this iron oxide hydrates with the just water and changes in a red brown substance that is called as rust over here. So this was about the rusting of iron. Now the time to discuss about the prevention methods of rusting of iron. For this, first of all, we will go by applying different substances. How we'll go with the further, go through with the mechanism properly. As I told you, this is very important process. So we'll go with the further by applying different substances as a protection of rusting of iron. Which of the substances can be used to protect the corrosion of iron? So listen me carefully, it's too important because of it will be a lot of question in your syllabus in board examination also. So first of all, by applying the different substances, so we can say that along with this, by applying oil, grease, paints and different metals such as aluminium, zinc and chromium just over the metal surface, especially for the iron, we can protect, we can decrease just probability of rusting of iron पर्टिकुलर इन मेटल्स का उस आयरन की सरफेस पे कोटिंग करके हम पर्टिकुलर इस रस्टिंग ऑफ आयरन को कम कर सकते हैं. जस्ट सेकंड फैक्टर इज sacrificial protection means sacrifice करना है, तो particular by applying Zn metal. The process is called as galvanization. By applying the Zn metal over iron metal, we can protect Fe surface. Here just Zn degrades and protects to metal surface. यहाँ पर्टिकुलर Zn जो है वो डिग्रेड होती जाएगी और आयरन सरफेस को प्रोटेक्ट रखेगी. यहाँ आयरन के लिए Zn ने अपना सेक्रीफाइस किया है, दैट्स व्हाई इट इज कॉल्ड ए सैक्रिफिशियल प्रोटेक्शन. नाउ द थर्ड वे, that is your by just cathode protection. By cathode protection, it is also important. This kind of the protection is used to protect underground pipelines and bottom of ships. जहाज का बॉटम जो है उसको और अंडरग्राउंड पाइपलाइंस को प्रोटेक्ट रखने के लिए पर्टिकुलर कैथोड प्रोटेक्शन का यूज करते हैं. हाउ? लिसन मी केयरफुली. So if we'll go with this process, then suppose this is the underground pipeline और इस अंडरग्राउंड पाइपलाइन का कनेक्शन, इस आयरन के पाइपलाइन का कनेक्शन Fe पाइप पर्टिकुलर एक मैग्नीशियम के ब्लॉक से कर दिया जाता है, Mg ब्लॉक से, कुछ इस टाइप से वायर के थ्रू. उस पोजीशन में पर्टिकुलर Mg ज्यादा एक्टिव है, सो इट चेंजेस इन Mg+2 by the loss of 2 electron. It acts as an anode and these electron shifts over here and it acts as a cathode. तो कैथोड बना करके यहाँ डिग्रेड होने से बचा लिया. This is called as just cathode protection, which is used to protect just underground pipelines and the bottom of the ship. Now, fourth way is by addition of different anti-rust substances as chromium, yeah, just you can say chromate, and phosphate salt in the metal. We can protect them by corrosion. So this was about the just corrosion and protection methods of the corrosion in deeply. So, dear doctors and engineers of the near future and chemistry lovers, this was about the entire part of the electrochemistry. हर एक वीडियो के अलोंग प्रॉपरली आप अच्छे से पढ़ें, डाउट्स निकालें अपने डाउट्स थ्रू द व्हाट्सएप नंबर 9829198271 पे आप शेयर करें. If there is any requirement regarding to this question paper as a chapter wise, you can share your problem with me. और अपना प्यार अपना सपोर्ट यूं देते रहिए. नो डाउट कारवा जरूर बनेगा. धीरे धीरे हम टाइम को भी हमारा बढ़ रहा है पर्टिकुलर और सब्सक्रिप्शन भी बढ़ रहा है, व्यूअर्स भी बढ़ रहे हैं. नो डाउट विल सक्सीड ऑल्सो. वो सब बच्चे भी जुड़ पाएंगे जो कि बहुत दूर थे और डेली 1-2 स्टूडेंट्स के अपने न्यू स्टूडेंट्स के प्रॉब्लम्स भी आने लगे हैं, अपनी प्रॉब्लम भी शेयर करने लगे हैं. सो यूं ही कंटिन्यू रखिए. फिर मुलाकात होगी एक नए टॉपिक के साथ नेक्स्ट वीडियो में, क्योंकि दिस वाज द अबाउट द एंटायर पार्ट ऑफ द इलेक्ट्रोकेमिस्ट्री. टिल देन धन्यवाद, शुक्रिया.